Hey guys, welcome to our channel. In this video, we shall learn about series and parallel circuits. You might have encountered both these terms a lot. So what do these terms exactly mean? Series and parallel are just two basic ways to connect the circuit components together. Let us first see what a series circuit is and how it works. So what is a series circuit? Components connected in series are connected end to end along a single electrical path. So a circuit which consists of only components connected in series is called as a series circuit. As you can see in the given circuit, the light bulbs are having end-to-end connections and the current flows through a single path. So this is a good example for the schematic of a series circuit. Now how does the circuit actually operate? In a series circuit, the current remains the same throughout the circuit, but voltage gets divided. The total voltage across the circuit is equal to the sum of the individual voltage drop across each component. To understand that, look at the circuit shown. It has three resistors R1, R2 and R3. The total voltage V gets divided across these resistances as V1, V2 and V3. Using Ohm's law, that is V is equal to IR, we find the voltage drops are V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. On further simplification, we get the equivalent series resistance is equal to the sum of the individual resistances. That is, R series is equal to R1 plus R2 plus R3. So this is how a basic series circuit works. Now let us see where this type of circuit is used and what are the advantages of using this. Some of the advantages of the series circuit are that it doesn't overheat easily and the connection is quite simple. Many loads can be connected to the same supply. Street lights are a very good example for this type of circuit. Now if you remember, I mentioned another type of circuit in the beginning, that is the parallel circuit. So what is a parallel circuit? Components connected in parallel are connected in multiple paths and the components are connected across the leads. That is, they are connected in parallel branches. A circuit consisting only of parallel elements is called a parallel circuit. How does the parallel circuit work? In a parallel circuit, the voltage remains the same across all the branches, but the current gets divided. This is exactly the opposite of what we saw in the series circuit. As you can see from the figure that the total current I gets divided among the three branches as I1, I2 and I3. But the voltage across all the branches is equal to the supply voltage, that is V. On further simplification using Ohm's law, we get the reciprocal of equivalent parallel resistance, that is 1 by R parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is how the parallel circuit operates. Now, you might be familiar with the fact that for many practical applications, generally parallel circuits are preferred. Did you ever wonder why? Let's find out using a small experiment. In the given setup, there is a series circuit. In this setup, the LEDs, the resistors and the supply, that is the 9-volt battery, are all connected in series. Initially, both the LEDs were turned on, but you might have noticed that as soon as I removed one LED, the other LED also gets turned off. What do we observe from this? In a series circuit, if there is any discontinuity or break in any part of the circuit, current immediately stops flowing completely. That is, the entire circuit stops functioning. So this is a disadvantage, right? Now let us go to the next setup. Now if you have understood what I explained earlier, you can notice that this is a parallel circuit. The LEDs and resistors are all connected in parallel to the supply. Now, like I did earlier, I remove one LED from the circuit. Now you saw that even when I removed the first LED, the second LED is still glowing. The red LED doesn't stop glowing. So from this we can notice that in a parallel circuit, even if there is a break in one branch, the current still flows to the other branches. This is a huge advantage. Now let's see how we are using this in our day-to-day lives. In parallel circuit, we have seen that voltage across all the branches is the same. So appliances having different current rating but same voltage ratings can be connected together. In our house, if you see all the appliances, they all have the same voltage rating. That is, the voltage we get from the power grid is 220 volt. So all the household appliances are rated at 220 volt. But all of them have different current ratings. But they're all connected together, right? Because we use parallel connection. Similarly, you may have noticed in functions and all we use decoration lights. They are also parallel. And on our power grid also, the generators which produce the electricity, generate the electricity are all connected in parallel. This is mainly because of the advantage mentioned earlier. Even if one generator stops working or there is one defective LED in the decoration lights, the rest of the system is not affected, right? So this is why we use parallel circuits in many practical applications. I hope you have understood the working of series and parallel circuits and also where to use them. If you like this video, please subscribe to our channel to watch more such videos.